Hello, I'm Michael Asbury, founder of Elevate Coaching and Consulting. I'm a certified Lean Six Sigma Master Black Belt and Theory of Constraints Jonah. Today's webinar is part 2 in a 4-part series, and it's going to be on the basics of TLS, which is the combination of Theory of Constraints with Lean Six Sigma. This is part of a 4-part series. The first one was making a strong comeback with TLS. Today we're talking about basics of TLS. The next one is the chain of solutions. And finally, we will go over charting your roadmap to efficacy. All of these are with the integrated methodology for improvements, combining theory of constraints and Lean Six Sigma. So what we want to do is we want to go from everyone in the organization working on their own thing and going in their own direction to a very aligned organization that is overcoming obstacles and challenge in a very systematic and methodic way with a high degree of alignment and very effective in achieving results. So we want to revitalize the flow in our organization and make a strong comeback as the economy reopens. So in order to do that, this webinar is about applying TLS to stabilize where we're at, enhance our flow, and then increase it. So in order to do that, we need to assess where we're at, plan on how to get to where we want to go, and then execute that. And this means we have to have a good understanding of the demand, the supply, and our capacity, the dynamics of those. So as the pandemic hit, a lot of organizations may have had a little bit of sales continuing in their backlog, and then a lot of them sales dramatically dropped off. Some even went to zero, and some are actually pretty strong and have even had an increase in sales. But we're going to look at the case where, their demand has reduced. So when that happened, a lot of organizations tried to see what they could do to reduce their expenses because they need to stay profitable. And unfortunately, a lot of the fixed expenses keep the red line higher than the green line here. And so profitability is lower now than it was. So if this was the baseline profitability for a lot of organizations now, it's much less and sometimes even negative, okay? So what we want to do is focus improvement efforts and see what we can do to reduce the expenses that we have now in terms of defects, downtime, overtime, and inventory, and see what sales we can actually find and increase the flow with our existing resources so that we can get back to a level of profitability that was similar to the baseline, even if we are at a lower volume. Then we need to do a coordinated ramp up and find more sales that we can get through our systems and processes at the same time as we bring back some of the resources. And we want to do this in a coordinated way so that these lines don't cross so we can stay profitable during that period. And from there, we want to take what we learned in this period with our focused improvement efforts and continue to increase how much we can process through our organization while not increasing our expenses as much. So if we do this, we can be at a higher level of sales volume with a lower level of expenses and be at a new level of profitability. Okay, so first we're going to talk about the theory of constraints, which was introduced back in, I believe, 1984 by Dr. Eliyahu Goldratt and Jeff Cox, the book, The Goal. And the theory of constraints is a process of ongoing improvement that's intended to be at a holistic organizational level to help manage the overall organization. It has a mechanism for focusing improvements so that they'll have the most significant impact on the organization and helps prioritize them relative to each other. So some of the core concepts of TOC is that a system is a series of processes, and the flow of the system is limited by constraints. And at any given time, one constraint is more restricting than the others. And if you want to improve your system, you have to do something that actually has an impact at the constraint. A bottleneck and a constraint are sometimes used synonymously, and it's also referred to as a capacity constrained resource. And it's important to note that you may not have a physical limitation at your constraint. It may actually be a policy on how that constraint resource is allowed to be used and the rules of operating it. Okay. So think of your organization as a system of processes, and at any given point in time, the resource with the most limited flow is your constraint. Okay. So let's say we're in this system, we can get 10 units in sales, but we can only process through our entire organization 6. Okay. So here's an illustration to help with that. We go from a 3-lane freeway where we can travel 75 miles per hour down to a 2-lane bridge where we can go 45 miles per hour down to a 1-lane tunnel where we can only go 30 miles per hour. Okay. So when there's a low amount of flow, we have to slow down a little bit, but it's not that disruptive. You know, it might take us an extra minute to get through the tunnel more than when we were traveling at full speed out on the freeway, right? So we have plenty of capacity for a low amount of flow. But as flow increases, we start to see some interesting phenomenon. Although we're still going at 30 miles per hour here, back here, if these drivers are kind enough to let traffic merge, they can only go about 15 miles per hour. And back here, it's only 10 miles per hour. Okay. So 10 miles per hour is not really productive when they could be going 75 miles per hour, right? So if you're in an organization where these supervisors in these different departments, where we've got 1 lane versus 2 lane versus 3 lanes, if they're measured by productivity or efficiency, it's going to look like these guys are okay, these guys, you know, not so good, and these guys have horrible performance, right? So the leadership of that organization may be looking for projects to improve this area because this is where we've got the most resources available. We've got the most bandwidth. We can handle the highest speed, and it's the lowest performing relative to its capabilities, right? So they may be looking at capital projects to build an off-ramp here and a parking garage so that they can always stay active, right? And that's not really going to help anything come out the other end of the tunnel. So it's important to remember that the bottleneck controls the flow rate for the whole system. Okay. So how many of you are familiar with Murphy's Law? Basically, if anything, if something can go wrong, it will go wrong. So, oops, we've got downtime at the bottleneck. So they're having no flow. Back here at the bridge, we have no flow. And back here at the freeway, we have no flow. And this is not cool. Okay. It's not efficient or effective, right? So if the bottleneck flow stops, the system flow stops. If we keep operating these areas, even though we can't get anything through the tunnel, we end up with a pileup, right? We end up with a lot of work in process and things are actually even slower, okay? So let's move on to some of the basic questions of TOC. And this is from the goal. You start with, what is the goal of your system? What do we need to change in order to reach more of that goal? And what do we need to change to? And then how can we make that change happen? Okay, so we've got the 5 focusing steps is at the core of theory of constraints. So first we identify the system's constraints. Then we decide how to exploit the system's constraint, which means what can we do to get the most out of it? Okay, then how do we subordinate everything else to the above decision? This is how do we coordinate our non-constraints with the constraint to achieve the most throughput. And then if we still have a constraint, step 4 is to elevate the system's constraint, which means expand the bandwidth. And if at any time during the cycle, the constraint moves, then we go back to the first step, okay? Another core concept is processes are composed of dependent events. So if you consider your organization a system, and systems are composed of processes, those processes have a series of dependent events. So that means one step depends on steps that happen before them, right? So consider it like this and this must happen before that, okay? So dependent events are subject to statistical fluctuations. That means sometimes it takes longer to do these various steps. So the amount of time varies. And this is vital to keep in mind when we're making improvements if we want to have a tangible positive effect. So another key thing to keep in mind is that our behavior is determined a lot by how we're measured, okay? People react based on their performance metrics, and this can lead to local optimization, which does not equivocate to overall optimization of a system, okay? So from the haystack syndrome by Goldratt, one of the quotes in there is, "Tell me how you measure me and I will tell you how I will behave," okay? So this is happening at multiple levels in a system, from the executive leadership that's reporting to the board, to the directors and vice presidents reporting to the CEO, to the managers reporting to them, to the supervisors reporting to them, down to the operators reporting to the supervisors, okay? So the sum of local optima does not necessarily lead to the optimal performance of the whole organization. So if there's a conflict between the metrics, you're going to have different parts of the organization doing things that are good for them, but that may not be good for the overall system. So metrics often create or enhance the conflicts. With TOC, the three primary metrics are throughput, which is the selling price minus the totally variable cost, inventory, and operating expense. These are very important to help with making good decisions that are good for the overall organization. You can calculate net profit by subtracting your operating expenses from throughput, and your return on investment, you can take your net profit and divide it by the inventory, okay? So throughput, this is the money generated by the system through sales. It equals selling price minus totally variable costs, and totally variable costs are the raw materials costs, sales commissions, maybe some packaging and shipping per unit, and any other costs that are directly associated with the sale of each unit. So this means if we get one more unit, this is a cost that directly is proportionate to that one additional unit, okay? We don't take all of the overhead and divide it by how many units that we sold last year and then add that cost, okay? Because if we got one unit less or one unit more, those fixed costs are not changing per unit, okay? So we're not allocating costs. None of the overhead or the direct or indirect labor that's allocated. Inventory is the money that the system invests to convert, pardon me, this is the money that we use to purchase things that we intend to sell, okay? So this includes work in process and finished goods inventory, and we hold them at the material costs plus anything that we pay to the vendors. So we do not include value added from the processes, okay? This helps to avoid distortions created by inventory losses and the distortion by counting that as an asset rather than a liability, okay? Because if we did, that might encourage us to maximize our local optimum at the expense of the viability of the entire system. So and if we did that, that would discourage better decisions that could keep our inventories at lower levels. Okay. Then operating expenses is the money that we spend in the system to turn the inventory into throughput. This includes all the other expenses that are not totally variable. Okay, so this is where we put in the overhead and the depreciation of the assets, salaries and benefits, labor, and consumables. You know, and additionally like utilities and anything else that we have. So the reason labor is here is because through improvements with that same amount of labor, we could still get additional throughput. Okay. So some of the core TOC tools and methods are the 5 focusing steps, drum buffer rope, VATI flow analysis, the metrics, throughput accounting, buffer management, and strategic and tactical planning with the thinking processes, critical chain project management, irrefusable offers, and the distribution solution. There's a few more, but these are some of the core ones. Okay. So with lean, the core principles are value is defined by customers, what they're willing to pay for. That value flows through the organization in what they call value streams. So it's important to understand how that value flows through all the processes. And then we identify the waste and we create continuous flow by reducing the waste. And finally, we pursue perfection, always looking to get better. So that means reducing steps, increasing quality, and looking for better ways to satisfy customers. Okay, goals of lean, we want better customer satisfaction, higher profitability, higher quality. We want to do this with the least amount of effort and cost possible and as fast as possible. So I mentioned that value is defined by customers. Value adding activity is something customers will need to pay for, needs to be done right the first time. And typically that means that the customer needs to have some change in the experience that they have either through the product or the service. They have to be able to have to physically or psychologically experience that it is better. What they're paying for is better because of this activity. Okay, so we want to enhance these. We want more of it. We want to make that value better. We want to produce it faster, and we want to make it easier to produce. Okay. A business value adding activity, you can think of this like something the customer is not willing to pay for, but it has to happen in order to do a value adding step. Okay. Think about in sports when somebody passes the ball before the other person scores the point. Okay. So it's like an alley-oop. These are steps that need to be done in order to actually produce the value. So it either helps or it's required in order to do a value adding activity. We want to make sure that the effectiveness of these are maximized. So we want to improve the ability of the value adding activities by making sure that these are working. We want to reduce the effort that it takes to do these. So we want to reduce the time, the effort, and the resources required. And if we could eliminate them, we would. Okay, non-value adding activities are waste. These are things the customers are not willing to pay for, does not help create conformance to their specs, and it could also be something that's not done right the first time. Okay, we consider these a waste of time, effort, and resources. We want to eliminate these immediately if we can, and minimize them if we can't. So the main types of waste, the original 7 are overproduction, excess inventory, waiting, unnecessary transport, overprocessing or incorrect processing, unnecessary movement, and defects. I found a couple others that are pretty useful to consider as well. Creativity, this is not utilizing the expertise of the people that are closest to the processes that we're looking to improve. And space, this is just not utilizing what we have in an organized and effective way. Okay, Some of the core lean tools are value stream mapping, 5S or often 6S, standard work, mistake proofing, which is also known as poka-yoke, quick changeovers or SMED, line balancing, level loading, total productive maintenance, rapid improvement projects, also known as Kaizen events, 5 Ys, policy deployment, house of quality, which is quality function deployment, and visual pull systems, also known as Kanban, Andon systems, waste walks and Gemba walks, single piece flow, work cells, single minute lessons, spaghetti maps, and metrics boards, okay, or visual management. So this does not include every single tool in Lean, but these are some of the core ones that you can make a lot of progress with quickly. Now we're going to move on to Six Sigma. Core principles here is that once again, just like Lean, it's customer focused. It's heavily focused on continuous process improvement. It's sometimes considered a war on variation. People are equipped with tools and skills, and it's highly focused on controlling the process. Okay, so some of the basics of Six Sigma, the goal is to increase efficiency and effectiveness of the processes. And it's got a systematic approach to improvements. It's data-driven, and it utilizes project teams with structured project phases. We use DMAIC for improving existing processes and DEMODOV for creating new processes or products or redesigning them, okay? When should you use Six Sigma? When you don't already know the solution, and if the problem is widespread and it's not necessarily well defined, and it can also be used for solving complex problems, and also when a very small change could have a huge impact. So the phases of DMAIC for existing processes are define, measure, analyze, improve, and control. For DEMODOV, the first three are the same, and then once we have this base understanding, we move into designing or redesigning the process or product. And it's best if you can make changes in the processes and product together. And then you go through some rounds of testing and making incremental improvements based on what you're finding out. And then finally you validate and launch it. So these are some of the things, the tools and methods within Six Sigma. I'm not going to go through all of that. So I will go through some of the steps in the DMAIC process, because with TLS, this helps you to see how to combine them. And this could be in a 3-month project, or it could be in a Kaizen event, okay, very rapidly. So we go through define, measure, analyze, improve, and control. So we identify and select a project, develop a project charter, identify the problem and benefits of solving it, come up with objectives, define the scope, choose the team, set the timeline, come up with our communication plan, and so on, okay? So whether we're doing, you know, a 3 to 6 month Six Sigma project, or I should say a 1 to 6 month Six Sigma DMAIC project, or whether we're doing a Kaizen event, we still go through these steps. It's just how fast do we go through them, okay? And how much focus do the team members have to stay on task with this, okay? All right, so with TLS, we're combining theory of constraints with Lean Six Sigma to drive rapid improvements with the scientific and intuitive sequencing to the improvements, okay? So with theory of constraints, we have identifying and defining the goals. It's focused on improving constraints. We have buffer management. We've got strategic planning, and it's throughput driven. With Lean, we have customer value focused. We're identifying and eliminating waste. We have a high level of employee engagement, and it's pull driven. With Six Sigma, we have data-driven improvements using a structured problem-solving approach with teams, and we're reducing variation to increase the effectiveness and efficiency of our processes. okay? So it's goal-driven, focused, collaborative, data-driven, obstacle removing, and value increasing, okay? So the Synergies of TLS from the Ultimate Improvement Cycle by Bob Sprawl, a very big fan of his, okay? Theory of constraints is complemented by lean because it has tools to remove the waste, improve the uptime, standardize methods, and drive cultural change. And with Six Sigma, there are tools to measure and improve the process capabilities, reduce variation and defects, and gain better process control and provide data to gain the support that you need to get the resources and the prioritization that you need. Lean's complemented by TOC because we have better focus for impact of the projects. And it helps us to distinguish between policy and physical constraints. And throughput accounting helps us to quantify and justify the improvements to have huge returns on investment to help get our projects moved up the list in priorities. With Six Sigma, it helps us to reduce risk and variability and improve our reliability. It provides data to build a case for gaining the support we need from management. Plus, we have the scientific rigor of the DMAIC process and all the tools that we have that are available to help solve complex problems. Six Sigma is complemented by TOC for focus and throughput accounting for maximizing the ROI and the payback time, minimizing the payback time of our improvement projects. And with lean, we can get really fast results with complex analysis. I'm sorry, when complex analysis is not necessary, okay? So one of the things that I like to really do is we take the Six Sigma methodology with the focus of TOC and we put it in a package, the package of a Kaizen event to drive improvements very rapidly in a targeted area. Okay, the next thing I want to show you is the Ultimate Improvement Cycle by Bob Sprawl. Okay, at the center of it, this is basically showing you how theory of constraints and lean and Six Sigma work together, okay? Synergistically rather than imposing each other. So at the center, we have the 5 focusing steps of TOC: identify the constraint, exploit it, subordinate and coordinate non-constraints, and then increase our capacity at the constraint if we still need to. Then we have lean, identifying the value, making it flow, producing based on the demand from the customers as well as the other internal processes, and pursuing perfection. Then the outer circle, we have Six Sigma with identify, then define, measure, and analyze, improve, and control. Okay, so when we integrate this, we go, if we're going clockwise around here, we identify the value stream plus the current next constraints and the metrics. Then we identify and measure the non-value adding waste in the constraint as well as the variation and defects. Then we develop the plan to get the most out of the constraint that we can. So we reduce waste at the constraint, we reduce variation at the constraint. Then we come up with the plan to coordinate and subordinate the non-constraints to the constraint flow. Okay, then we execute that plan. And at this point, it's good to implement drum buffer, rope, and buffer management. And then we plan for to elevate the constraint if we need to, as well as develop our protective controls and use throughput accounting. Okay, and then if necessary, we elevate the constraint and implement the controls to sustain our gains. Okay, and these are several books by Bob Sprawl that I highly recommend if you really want to pursue TLS. Okay, so the tools, actions, and focus within the different phases of the Ultimate Improvement Cycle. We've got a value stream map for the current state. We've got our performance metrics, analyze inventory. We use the TOC thinking processes tools. And we also want to go and see what's actually happening in the processes once we've identified the constraint with the Gemba walk or waste walk. Then we use We do value stream analysis and determine waste and inventory, and do a current reality tree to see how our undesirable effects are related to each other. Look for some of the core things that we can improve. Then we do a capability study, use control charts, cause and effect diagrams, and Pareto analysis. Then we develop a plan for how we can get the most out of our constraint. We organize it with 5S, standard work, and visual aids. Then we can do design of experiments and use causal chains and conflict diagrams and intermediate objectives maps. We can synchronize our flow through the constraint, synchronize the flow with by using drum buffer rope and buffer management. Then we can optimize our buffer sizes and limit the non-constraint production. Then we plan for how and when we should elevate the constraint and what we're going to do to protect the new flow that we're designing. Then we perform our capacity analysis and do the cost benefit analysis, and we perform process audits, policy analysis, and use throughput accounting and control charts. Okay. So the results of these phases are we're going to have a complete picture of the system in terms of the flow, how the metrics would drive people behavior, and we're only going to be measuring efficiency or utilization at the constraint at this point. Then we develop our knowledge of where the waste and the inventory is at and what are our potential core problems for the system. We are also getting details on the type and location of variation and defects in the system. And we're developing a plan on how we can get more through our constraint and improve the throughput of the entire system. Then by executing our plan, we have a well-organized constraint. And then the next phase, we have a constraint that has very little variation. Then the next thing we have is a plan for how we're going to coordinate the rest of the organization based on the flow through the constraint. Then we execute it and we synchronize the non-constraints based on the constraint flow. Then we can reduce our buffer sizes by reducing some of the variation and disruptions and wastes in the non-constraints, which allow us to have less buffers. Okay. Then we develop our plan for when is the right time to elevate our constraint and how are we going to control the rest of the processes. By the next phase, we have an understanding of our new system flow, and we're using throughput accounting to anticipate what we need to do next and make day-to-day decisions on how do we react based on whatever our day-to-day challenges are. And then finally, we have our sustainment actions in place, the system's flowing well, and we have good indicators for making sound financial decisions. At this point, we may have changed things and we go through another cycle, okay? So when we are deciding where we're gonna make our improvements first, you could consider the system to have a flow, right? So if you wanna increase the flow through your system, you need to know where you need to focus first in order to have the most impact. So if we have liquid gold flowing through this pipe system, where would you focus your improvements first to have the most impact? D, right? And this comes from the first edition of Epiphanized by Bob Sproul and Bruce Nelson, by the way. So if you do D first, that's correct, followed by F, followed by B. If you follow that sequence, your improvements are going to have an order of magnitude more impact than if you just start implementing anything that you possibly can, anywhere you possibly can, okay? So we need to keep this in mind when we're selecting our projects and in the sequence that we're going to improve them. So now let's take a look at a high-level process map. So we have all these processes in our organization, all the way from marketing and sales, closing the deal, entering the order, scheduling it, purchasing what we need. The supply chain does its thing. We get the materials, put them away, get them back out when that order comes, when we started in operations. Then we do the steps of our process. Then we deliver our product or service, and that means it may go through logistics and distribution. And then finally, we have a bill and we deposit the check, right? So where in our system could the constraint possibly be? You know, it's not like a simple piping diagram now, is it? Okay, so some of the things you could look for are which process has the longest cycle times, where's the most work in process, who's working the most hours, or who's on weekends when no one else is, who's working the most overtime, and those are some clues. You can also be stuck in a rework loop. So you might have a process that's not the constraint, but because of defects from upstream, they might have a lot of extra processing time. So we may actually need to focus on where in the process these defects are happening and apply 5 whys to help stabilize our flow. Okay, so with our product mix, it's important to think about which product family has the most potential to increase our profitability. And so you can list all your product families, list all your main process steps, and then this is just a simple way to see which resources, which product families are flowing through. Okay, so just simply add a box or add an X in the box for which product family goes through which processes. Okay, so you can go to the next level with that same concept and list all your product families and list all your process steps, and you could draw a line through which ones they're going through, play a little bit of connect the dots. Okay, so let's say you want to focus on these 3 product families. Okay, so we would start to look for the constraints in that to improve. But one nice thing about this is some of the process steps are shared by multiple product families. So if we improve some of these processes, it's going to have a positive effect on other product families as well. Okay, so for instance, these that are shared by this other product line or another product line will also be impacted. All right, so as we've narrowed down which processes we want to focus on for our improvements, now it's time to talk about Fujiwaka, which is not a Japanese lean term. This is a way to identify symptoms and obstacles by talking to the subject matter experts. So we go and talk to the leadership or management and the employees of the area that we think we need to execute an improvement project, and find out what's making them frustrated, upset, disappointed, worried, angry, concerned, and anxious. Okay. The reason we're asking them these things is because people generally want to do a good job. They want to bring value to the company, and they want to be valued by the people that they report to. So when things are affecting them emotionally like this, these are good red flags that those same things that are bothering them are impacting the flow through that area. So then we measure. So we're going to measure our value added time, our business value added time, and our non-value added time in the target department. Okay, so let's say these are 5 stations within a department, and the red indicates a non-value adding step. Then we have 2 value adding steps, then a business value adding step, right? Then these diagonal lines are representing waiting time. So this station was done and that unit sat for a period of time before they began working on it again at the next station. Okay. So the top one shows the sequence in which the steps happened. This second one, we sorted it by value to business value adding to waste within each station. And then lastly, we organized it by through the entire department. So if we looked at it by the time that they were actually working on the unit, the breakdown of the value add versus non-value add looked like that. But if we looked at the entire time that it was in the department, it looks a little different, okay? So that was at the department level. If then we hone in on one of those stations, we could look at what's happening throughout a, for each unit that passes through there over a period of time. And you know, other people call this different things, but I call this a defragment map because it reminds me of back in the day when we used to always have to defragment our computers or they'd get slower and slower. So the idea is we remove the red and the yellow, right? Likewise, I'm calling this a fire chart because you can imagine if you have it sorted by waste on top, you can imagine as we make improvements, we're getting closer to the value add time. If you look at the green, it's pretty small proportionately, right? So if you do a time study and you observe the process and you sort it like this spells out what the things are that are inhibiting the flow. So you have quantified your obstacles and challenges that are restricting your flow at this station, okay? So now I'm going to introduce you to the chain of solutions. We will cover this in the next webinar. So imagine we picked our product family and then we identified which processes it flowed through, which are A through Z here. We've measured the cycle times at each of them, including the value adding time, the business value adding time, and the waste. And then we talked to the subject matter experts about what are their obstacles and challenges that are affecting them at each of these processes. So we talked to one group of subject matter experts at each of these processes, A through Z, and these red squares indicate those obstacles that they came up with, and we prioritized them from high to low, and then they came up with solutions to overcome them. So we developed all these obstacles and solutions with the subject matter experts based on how they ranked them. Then we measured them with our defrag maps and our fire charts, and we realized that if we want to have 20% improvement, we need to go after these obstacles with these solutions. So we came up with these 10 things we could do to get 20% improvement for the throughput of our organization. But also we have all these other ideas and solutions that they came up with. And so if we want another 20% improvement, we can do these 10 things. And if we want another 10% improvement compounded on top of that, we can do these 10 things, okay? And we'll get into this more in the third webinar, okay? So then we can drive continuous improvement. Imagine that we're using Kaizen events to rapidly implement these things in plan, do, check, act. But we can also go into a phase of continuous improvement where we're tracking our constraint or whatever our station is that we want to drive improvements. We track their performance versus a target, and we also track how many obstacles or issues they're facing on each day in that. And then we break those down by categories and where they're happening. And then we have subject matter experts in that area where it's within their span of control meet on this weekly. And then, as they start to knock off these obstacles, you can reduce it to, every other week or monthly. But initially I'd recommend weekly. They talk about which of these are their top issues, what do they think are the root causes, and who's going to do what by when to see if they can overcome those in the next week. And basically they're following plan, do, check, act in this phase, okay? So the results that you can get after applying the chain of solutions, something like this, where this is the process time and these are the steps, and this is your constraint. We have 10 units with varying process times. We've got an average here and we've got the range. So we go from something that looks like this to something that looks like this. So it's much more consistent. There's less variation. The average times have come down and they're getting more throughput. So if you were looking at the defrag maps, it may look something like this originally and then reduced, okay? And for some of you that are pretty advanced in this, you might say, well, why do we have all this wait time? And that's because we implemented drum buffer rope, and we want to make sure that this process has something ready for the constraint to work on. And as we reduce variation, we can reduce that buffer size, okay? Get even more throughput and have less inventory, okay? So the evolution here is we assess where we're at with our current state. We start moving into a rapid improvement project phase. Then we're starting to coach and train people on the change management process and training more people to be able to make improvements simultaneously throughout the organization, okay? Then we start executing improvements strategically with our value stream, our value chain partners, and then we drive it to value chain excellence. So it may look something like this. You can imagine you've got time on this scale and your effectiveness in terms of dollars on your vertical scale. So we go through a phase where we've identified what we need to change in our company, and we start driving rapid improvement projects. And then we get to a phase where, let's say we've improved our throughput by 20%. We may need to go into a continuous improvement phase where we're not getting additional throughput at such a high rate, where we're still improving it, but not as fast. We're not doing as many strategic improvement projects internally, and we've gone into a continuous improvement phase while we are helping our value chain partners go through a phase like we did first, so they can keep up with our growth, okay? Then we can do another phase internally, and then we might need to look at another phase with our value chain partners, and then internally again. And as we do this, we are going beyond the limits of traditional performance in our industry, okay? So the benefits, our customers are going to have improved on-time delivery, lead times, and quality. Our company is going to have the benefits of having more sales with the same resources. Our inventory is going to be reduced in terms of raw materials and work in process and finished goods. We'll have higher inventory turns, which equivocates to better cash flow. Our operating expenses will also come down. We'll have less material waste, less rework, less overtime, less turnover, and the employees will be more satisfied because they got to participate in this. They understand their own processes better, as well as how they fit within the big picture. They're going to be able to accomplish more. They'll be more effective. They'll have less effort and frustration with the efforts that they're putting in to get their results, and they'll have more confidence and pride. This also gives them the opportunity to have potential for higher job security, better benefits, and increased pay because the company has more that it can actually share, okay? And then typically the suppliers are also benefiting because as our throughput increases, we purchase more from them, okay? So I've got a lot of training that I can do to help organizations with this. So if anyone is interested in doing that, then you can reach out to me. We have some scheduled coming up here in June and July, and here's a link to get to that, as well as these webinar videos and additional webinars that will be coming up on case studies. So if you have any questions, reach out to me and let me know. Thank you. Have a great day.